Hey guys, Mr. Cubby here, and what we're going to talk about in this video is derivatives and integrals of e to the x or e to the u, where u is a function of x, and also integrals of e to the x and e to the u, where u is a function of x, and also derivatives of exponentials where the base is something other than e, and integrals of something of the basis, integrals of functions where the base is something other than e. Okay, so it's a lot of stuff mixed together. None of it's hard individually. It's just kind of hard to keep it all straight. Okay, because we're going to talk about derivatives and integrals and bases of e and other bases. Okay, so we're just going to basically see a bunch of derivative integral rules, / remind you about them, and then do some problems. So what's the derivative of e to the x? Easy peasy, e to the x. Oh yeah, by the way, this is in the big note packet on page, what page is it on? 29, 27 by the numbering in the bottom corner, 29 by the PDF numbering. Anyway, derivative to the x is e to the x, easy. What's the derivative to e to the u? Well, here we're talking about u being some function of x other than just x. Well, the derivative of e to the u is e to the u times the derivative of wherever that u is. We got to do some chain rule. Okay? All right. So then, hey, you could definitely do a problem like this. Why don't you pause and give this problem a try? We're trying to find the equation of the tangent line to this function at this point. We already got the point. All we need is the slope. We need to do the derivative of this. Pause, give it a try. I'll show you the answer in a second. Okay. So for this first chunk, you have to use product rule. First times derivative of the second. Derivative of e to the x to the negative third is e to the x to the negative third times negative 3x to the negative 4. First times derivative of the second plus second times derivative of the first. Derivative of x is just 1. That's why it's not there. Derivative of ln of something is 1 over that thing times negative 2x. You can just put the negative 2x right there. Okay. Plug in the point, write it point slope. Okay. Cool. Okay. A couple other derivatives, just to get your brain working. Pause, give 2, 3, and 4 a try. And we'll talk about 4 if you forgot about 4. Give 2, 3, and 4 a try. Okay. Product rule. Product rule. The second part of product rule, and it involves a little chain rule here. Note that on a multiple choice, you might see someone look at this answer and say, hey, I'm going to GCF out an e to the negative 5x and write it like this. Okay, you could leave it like this if it was for your response. Second one is you got to use double chain rule here. What's the derivative of ln of sine of e to the negative, or e to the x? 1 over sine e to the x times cosine of e to the x times e to the x. Which you can write like that. Simplify it if you want to cotangent. This is a function where y is not by itself. So when you do the derivative of it, you need to use implicit differentiation. What's the derivative of e to the xy? Well, it's just e to the xy times the derivative of xy. What's the derivative of xy? First times derivative of the second. What's the derivative of y? 1 dy dx, or y prime. Plus second times derivative of the first. What's the derivative of x? Just 1. Normal derivative. Derivative of y squared is 2y times the dy dx times a y prime. Then you got to get the y, there's a few steps skipped here, so I can show you guys those if you want to check. You're going to have these terms. And because there's multiple terms with the y prime, you're going to want to keep the terms with the y prime on one side, move the terms without a y prime over to the other side, GCF out a y prime, and then divide it over. I can show you guys that real quick. It's just a little cumbersome. Negative exy minus 2x over here, meaning we're left with these guys on the left side. I'm going to GCF out the y prime. I'm left with this. And then I'm just going to divide both sides by that. And that's my answer. A little implicit differentiation, don't forget that. Overall, doing derivatives of stuff with e to powers is not bad at all. Okay? Let's move forward. When you're based on something other than e, you have to make an adjustment. Okay? What is the adjustment you make? Well, the derivative of a to the x is just a to the x. But you have to make an adjustment, and the adjustment says you have to multiply by the ln of a. That adjusts for the fact that the base is not e. E to the x's derivative is itself. Another exponential's derivative is kind of itself, but you have to make an adjustment. That's how I think about it. If the other function is a to the u, so it's something other than e as the base, and the exponent is a function of x, then you have to make two adjustments. The derivative of a to the u is a to the u, adjust for the different base, and do the chain rule. Please note that those two things that you tack on there are like tacked on for different reasons. Okay. Very similarly, what's the derivative of ln of x? Well, the derivative of ln of x is 1 over x. So what happens when you have a log with a base other than x? Excuse me, other than e? Well, when you do the derivative, you just need to account for the fact that your base isn't e. No? You do an adjustment. You add an ln of a. Cool. Please note that you add that ln of a in the denominator. It's a little confusing there, but just make sure you keep track of that. So what happens when you're doing the derivative of a log that has a base other than a, and the argument isn't just x, it's another function? Well, you have to adjust for the base and do the chain rule. I do 1 over x, adjust for the fact that the base is a, not e, and then do the chain rule. The chain rule always happens in the denominator, or in the numerator. Chain rule doesn't happen in the denominator, just that adjustment happens down there. Cool. Nothing too tricky here, you just got to keep track of it all. Okay. So then how do you do the derivative of 4 to the x? This is 4 to the x, adjustment. Sorry, I was about to write ln of a. Come on, Mr. Covey. Adjustment for the fact that the base isn't e. How do you do the derivative of g? Derivative of an exponential is just itself. That's always true. Adjust for the base being not e. Adjust for the chain rule. Please just note that these two multiplication things here are there for different reasons. Chain rule, base not e. We talked about this in class. If you're doing the derivative of something that looks like this, why don't you take advantage of the fact that it's a log and use some log properties? Why don't we split this up? I'm not doing the derivative yet. I'm just splitting it up using log properties. That way I don't have to mess with the derivative of a log and the quotient rule at the same time. Now that I've split it up, what's the derivative of log base 3 of 2x minus 5? It's 1 over 2x minus 5. Adjust for the weird base. Chain rule. 1 over 3x plus 8. Adjust for the weird base. Chain rule. Okay. There's those answers. There's a 1 over ln of 3 GCF out. Not a big deal. Okay. Moving forward. We're switching our mindset now to integration. We're working backwards. What's the integral? What's the indefinite integral of e to the x? Well, it's e to the x plus c. If you have an exponent that's not just x, as long as you get a du next to it, the antiderivative is just e to the u plus c. Remember here, u is a function of x. All we're reminding you here is that like you need to account for u, or excuse me, you need to do that u sub process basically. So like the antiderivative, or we'll just see a problem in a second. Cool. Again, none of these rules individually are that bad. You just got to make sure you kind of keep them all straight. So then how do you do the antiderivative of e to the x? Technically, you should do a u sub. If you guys are getting to be big calculus boys and girls and you don't need to do this u sub, totally fine. But if you want to still, you always can. I want to have a 7d to the x. I'm going to introduce a 7. I balance it with a 1, 7. I have an e to the u du. What's the antiderivative of e to the u du? Just e to the u. At a 1, 7 chilling, put the plus c, toss it back in terms of x. It's kind of like a wrap. And Mrs. Lemke used to be a rapper. Yeah, back when she was in college. But she hasn't told you about that. Anyway, moving on here. You guys take a second and try this one. Okay, do a little simplifying first, a little monogram. Go for it. We'll talk about it in a second. Okay, you monogram it. Rewrite it like this. It's going to help to write those exponents as negative rather than fractions after you monogram it. Note here, we're just splitting it up and pulling out the coefficient. And then from here to here, you can do the u sub if you want. You can draw your cards and do the u sub, or you can kind of just think, if I have an e to the negative 3x, I'm going to have a negative 3 tacked on, which I don't want. How do I balance that? With a negative 1/3 out front. And that's why this 3 and the negative 1/3 create a negative 1. Same thing here. There's an e to the negative 2x. Well, I have to account for that negative 2x with a balance of a negative 1/2. That's why I have a plus 1/2, because it's minus negative 1/2. You can do u sub if you want. For those really simple ones, though, you don't have to if you don't want. Okay. Last one here. A little tricky. This reminds me of square roots. Want to know why? Because square roots are one of the things whose derivative involves themselves. You know, like the derivative of the square root of x is 1/2 square root of x. And the derivative of e to the x is e to the x. So they both kind of have that in common here. So think about that when you decide how to do this. If you're really stuck, got an inside part, take that inside part u and go from there. Drop it up here. Here's my cloud. Called that inside part u. Its derivative, like I was saying, its derivative has the same thing in it. So when you're seeing that, it's going to end up working out with the du. Here's my u. Here's my du. Here's me just cleaning up my du. I wanted to get the du in there, so I had to insert a negative 2, balance it with a negative 1/2. I ended up with this integral. Toss a du there. What's the integral of cotangent? Ln a sine. It's one of those ones you have to memorize or derive. Don't forget to change it back. Oops. Should be sine e to the negative 2x. Cool. Moving forward. Okay. This is the most confusing one for me, which is the integral rules for bases other than e. Take these slow. The way I think about this is I remember the derivative rule for a to the x. The derivative of a to the x is a to the x times ln a. This is the adjustment for the base not being e. When you integrate, you have to make that adjustment as well. You make that adjustment backwards. So the integral of e to the x is just e to the x. The integral of a to the x is not just a to the x. It's a to the x with an adjustment. I have to adjust by ln of a, but I have to make that adjustment backwards because this is an integral rule, not a derivative rule. So what's the opposite of multiplying by ln of a? Dividing by ln of a. That's the adjustment. Okay, I know it's a little confusing. Again, you can check that antiderivative rule by doing the derivative. What would the derivative of this be? Well, it'd be a to the x times ln of a, and then you have that ln of a, and then those would cancel, and the c would go away, and you get a to the x. You can always check your antiderivative rules by doing the derivative, don't forget. This is just a reminder, same thing. that if you have a function base to a power where the power is not just x, but it's a function, keep in mind that u sub idea. Okay. Okay. So then what's the antiderivative of 2 to the x? Well, it's just 2 to the x. Only I need an adjustment. And since it's an antiderivative, I'm going to do the adjustment on the bottom. That's how I think about it. You guys want to do this together or by yourselves? Together. All right, well, we'll do it together. We got two chunks here. This is a polynomial. This is an exponential. It's a product, so I can't just like do them individually. I'm looking, I don't know. No. The exponent here is 1 degree more than the outside part. It's kind of like an inside part. This will be a u sub guy. Let's draw our u. U is going to be the inside part, the exponent. So then our du is negative 3x squared dx. You guys take it from there. Actually, no, let's do it together, whatever. All right, so I want there to be a negative 3 in there. I'm going to, this is how I like to do it. I'm going to pull that 4 out. I want there to be a negative 3. I'm going to balance it by dividing by negative 3 out here. So now I'm 5 to the u du, negative 4/3 out here. What's the antiderivative of 5 to the u du? Well, just 5 to the u. Balance with an ln of 5 in the denominator. And then I have this negative 4/3 plus c. Don't forget to toss back in whatever we called x. Cool. Now if we want to kind of clean it up, we could write it, I guess. Don't forget to plus c. Negative 4 times 5 to the negative x cubed over 3 ln of 5 plus c. Cool. Lots of different ways to clean that up. Next one here is a little tricky. Take 30 seconds to look at it, think about it, and then we'll come back and chat together. Just think about how you do it, or start trying to see what you think is going to work. So my initial thought would be, I wish I could do monom-denom. Because the addition's in the denominator and there's single terms in the numerator. I'm really struggling here. I cannot do anything like this. Please do not do anything like that. That is highly illegal. But again, it's going to use the fact that the derivative of exponentials involve the initial function. And that's going to help us get some good implications for u sub. So if you make the u 7x plus 4, well, du is 7x ln of 7 dx. Basically is the numerator, shows up in the numerator. So I'm basically going to end up getting one of these guys. Boom, 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 boom. I need to introduce an ln of 7, so I balance it with a 1 over an ln of 7. And now I'm here. So the fact that the derivative of 7 to the x plus 4 involves itself allows you to use u sub here. Make the u the denominator and its derivative basically shows up in the numerator. Okay, here's that one finished up. So it's just that. We're basically done anyway. Cool. Okay, that concludes this video. In summary, none of these rules individually are that bad. Just really try and keep them straight. Also, make sure you're keeping straight whether we're doing derivatives and integrals. Since we're intertwining those, it's easy to get them mixed up. We'll do lots of practice. Don't worry. Thanks for watching.